Thanks for everyone tuning in, especially at this late hour. Much appreciated. In this talk, I'll be talking about Nushell. Before I talk about what Nushell is, let me just give a tiny bit of backstory. So Yehuda Katz, who folks coming from different areas may have heard that name a few different ways, which is kind of fun. Yehuda worked on Ruby on Rails 3, works on Ember.js, and also helped create the cargo tool that we use for building our Rust projects and getting the dependencies. So Yehuda, who's a friend of mine, was playing around in PowerShell and said, this has some really cool stuff and not enough people use this thing. How can we take some of these ideas and continue to grow them, but maybe grow them in a way that makes sense from a Rust perspective? So he started this project on his birthday, called it Object Shell, and I was like, cool, let's go, let's see where this thing goes. I had actually, unbeknownst to him, started my own shell project around the same time. Had different ideas. I wanted to take some of the ergonomics and usability that I wanted to see in a shell. And so we were talking right after he started his project, and I said, oh, that's a good idea. Can we merge? He's like, absolutely. So we merged our projects together, renamed it Nushell, and then I contribute, skip, and where, and we'll see what those are here in a second. So this is starting, around May of 2019. And it's the ideas, I guess you could say, are almost in reaction to PowerShell, if that might be fair to say. So if you look at PowerShell, it's very much created from the perspective of someone working in .NET, working in C#, and wanting to expose that functionality to the world. So it's very object-oriented. It has different object types that represent different types of things, so files and services and whatnot, all these different objects in the system, uses methods, and the variables that it uses are mutable. So everything just kind of follows and flows from how you might design a shell coming from C#. With Yehuda and I both being kind of Rust converts, I guess you could say, at this point, we'd both been using Rust for years. So we, like Tim was saying, as you become more idiomatic in Rust, you begin to use things like iterators all the time. Data becomes separate from the commands, and you use kind of a compositional style, a functional compositional style. So we wanted to kind of have that in a structured shell perspective. And also because Rust is immutable by default, we wanted Nushell to also take this on, so that as you're working, it would be easier down the road as we added, parallelism and parallel data processing, that all of it just works. You don't have to be thinking about what's mutable, what's safe, and this kind of thing. So a lot of it is Nushell's kind of being born from this idea of a structured shell, but in a much more Rust direction. So the kind of goals of this, all right, like I was saying, it's very data first. Everything is immutable. Everything is structured data. As we find out, one of the inspirations for it early on is the Serde project. And I think Tim even mentioned Serde in his talk. So Serde, being the serialization, deserialization system that's quite widespread use in Rust, has inside of it a kind of universal data structure, a universal value type. And if we can, take a bunch of different data sources and create this universal value type, then we can create a bunch of commands that can filter it, and a bunch of other commands that can manipulate and use this data, present this data. So we are really inspired by Serde's universal data type and said, why can't we just introduce into a shell structured value type that you can build up? And I'm going to show examples here in a minute, but this is kind of the real foundation for where we started to come to the design of Nushell, is looking at Serde and saying, can we apply these to a structured shell? It's ergonomic. My background is in developer tools. So like we were talking about, I worked on TypeScript. I work on Rust error messages. I really care a lot about if you do something wrong, that we hurt as little as possible. So we present you a very attractive error. We present the system and its data in a very attractive way, so it feels fun. Like you want to use it. You want to pick that up over, other tools, because it really engages with you. It really feels comfortable to use. And as we'll see, it's a structured shell in that as you build the pipeline, in a traditional Unix shell, pipelines take strings and pass strings of text through these pipelines. So you can compose together multiple Unix commands into a much more complex command, but each one has to handle like text data rather than structured data going between the different commands. And we wanted to flip that. We wanted by default everything to be structured data as the commands compose. I'll show a little bit of how that works here in a minute. I saw this tweet the other day and I said, that is a great that is a great quote. Feels like having a Jupyter notebook cell embedded in the terminal. Like I'll just let that speak for itself. We'll see if you think that that's the case when I actually show the demo. So let's show the demo. So give me 1 second and we'll switch to the demo. All right. So this is Nushell. As you can see, it looks like a normal shell. It looks like bash or fish or any of these other shells. It's got a prompt and I can type commands. So the first one I'm going to type is just ls. So when I type ls, you can see that it's a table. It's got some columns at the top, and each of these columns is, a column of data. For an ls, I get, a set of file names, a set of types, size, and modified. If I do a different command, so I might do ps, and that's my list of processes for people that want to know what's running on my system. And you can see it's the same kind of idea. We have tabulated data. They have different columns and different values in the different columns. If I want to, for example, now use this data, it's not just that I'm printing out a table. Like, that would be neat. That would be attractive to just print the table. But this data itself has structure to it. So if I wanted to say where size is greater than like 10 kilobytes, I can take the structured data coming out of ls, pass it into this filter, this where command. And by saying where, I actually down select or filter down to just what matches this. And you can see there's a lot of inspiration for Rust going on behind the scenes. ls is giving me an iterator if you look at the actual implementation. So it's giving me an iterator, and then I'm creating a new iterator using this where command. So I'm just kind of building and building and building until I get an iterator that I pull on at the end. And as I pull on that data, I have the elements that match all of the different stages of that iterator. This where command is working on this universal data value type. So if I said ps, and we'll bring ps up. If I want to say ps where, let's see what our column names are here at the top. And let's say where mem is greater than some certain size. We could say ps where mem is greater than, let's say 10 megabytes. Oh, here's an example of me mistyping something. So it says, hey, you created a string here, and this is a file size. So 10 MV, it gets turned into a string because it's not a value. But that is, so if I say 10 megabytes, then I'm actually filtering down the processes to those that are larger than 10 megabytes in size. Let me show one other example real quick. If I do open cargo.toml, which is something that we do quite a lot, opening data files like toml files and XML files, JSON files themselves also give us tabulated data. You'll notice that in some cases, like with listing a directory or listing the file entries, that's all nice and flat columns. Here we have data structured inside of other data. So this is how we handle something that's more like a tree or more like a more complex data structure. And then I can, of course, do the same thing. Like if I wanted to run a command over top of the structured data, maybe I want to get out bin and see all the binaries that new ships with. And so here we go. So it ships with a bunch of plugins, and then I can continue to manipulate it. Notice, like as I'm building it up, I have a set of commands that are generating the data that I'm working with, a set of commands that are filtering that data. And as a user, I just have to learn what you might say like im plus n, like im number of commands that can generate in commands that can filter. And as I build my vocabulary, I can reuse it everywhere because we're just using one value type, one underneath. It's like an iterator of this value type. Then I can just use the same set of commands regardless of where this data is coming from. All right. So let's see. I'm kind of looking through my notes. Oh yeah, and this is something that I kind of mentioned in the early slides. These aren't objects. This is just like real structured data. They don't have methods on them. We don't mutate them or anything like that. But we just build up the pipelines. The next thing that I want to do is to let's build up a command of our own. So I'm going to say, let's make one called largest. It's going to take, and you notice it's highlighting red because it's telling me, hey, this is an incomplete command. There are major parts of this thing missing. You need to make sure that you at least provide these parts. So we'll say the largest X, or like count, be the largest number of files in a directory, and we'll give it a count for the number of files we want. So we'll list the directory, and then we'll sort by the size. And then from there, we'll grab, like, say, the last count. Right. So if I say largest 3, I'll get the top 3. If I say largest 5, I'll get the top 5, and so on. This definition now has contributed a new command into the system, and now it interacts with everything else. So if I say largest 5, I notice, hey, there's some directories in here. So I can say, well, where type is not directory. And then I can filter it more. So it's not that at any point we're printing out the table. You can think of it more that this whole thing runs, and what comes out of this pipeline is, again, an iterator. And we only see the values on the screen when the very last stage happens. And that's called auto viewing. It's going to take that iterator and then finally show you the contents of that iterator on the screen. All right. So this is the largest. We get the values out. Oh, one other thing I want to show here as well is that, coming from TypeScript and coming from gradually typed systems like TypeScript, being able to put in type information, we can do this here as well. So I can say that this count is an int when it comes in. If I try to say something that is not okay, so I say foo, it says, hey, you said that it was going to take an int, and instead you gave it a string. And so you can't do that. This, kind of light type checking and how you can build up commands then allows you to more easily scale this up to writing full scripts. And there are people that have taken Nushell and used it for doing much larger data processing systems, or I say large, I mean large for a project that is still very much in its infancy. So they've got, many files and a lot of Nushell source for just doing different kinds of data processing. Okay, so we can do optional types. I did show error messages. I think one of the ways to think about Nushell is that it's an IDE in the terminal in some ways. So we've got completion. So if I start typing largest, I can get a completion for that. If I say new dot, New is a dollar sign new is the built-in variable that gives you access to some things like your history path, and you can see, okay, this is where my history is being stored. So we have some of the completion logic, and we're building a bunch of new completion logic as well, so that it feels again more like a very nice shell, like fish, or like even like being in an IDE in your terminal. Okay, I have to show this real quick. I didn't prep my emojis. I made this note. I made this as a tweet the other day that you can say, let shark equals 5, and then you can echo shark and get 5 out. So the parser is very it's very powerful. It's very flexible. And actually, I want to take 1 second to explain some of the stuff that's going on behind the scenes. And I'll leave maybe some for questions or chatting on the Discord. But I want to take you through how the parser in Nushell works. So for example, if I try to do, let me do that where again. I can ask the system about where. I can say, help, where? And it will give me some examples here at the bottom, you can see. And at the top, it tells me what the parameters are to where. Notice that here, where has a single parameter called condition. And if you look back at the top, it almost seems like if you implemented this as day 1, you might take 3 parameters to where and then just kind of make it work. But what's actually happening in Nushell is that it sees a single parameter. It sees that the type is condition. And then as the parser parses, it configures itself. It says, I expect a condition in this position. So these 3 size greater than 10 kilobytes become a single thing that the parser then gets configured to look for. What's actually happening is that once it's parsed, so it kind of switches into a mode that can pass mathematical expressions. And then what comes out looks like, let me just write this up, where, I'll do the full thing, where it, then it dot size greater than 10 kilobytes, right? It kind of looks like this. It expands that smaller expression that's easier to read, easier to write, but it expands it into a full expression. And here we can see some of the bars that Tim was talking about. So you can see Rust shining through in certain places. But here we have a block. It has a single parameter called it. And it is the name of each of the rows. You can think it as iteration. So as you go through each row, you can access the column and its data and then compare it to something else. So this kind of type directed parsing is something that I have not seen in very many languages, if at all. It's been kind of a research topic back when I was in grad school for programming languages. It was a research topic then. So that's, back in 2011, 2012. And really it hasn't really made its way out. And in a shell like this, we have such flexibility because there's already a sense of what does it mean to pass arguments into a command. And it gives us a lot of flexibility to say, all right, let's make macros or type directed parsing part of this so that it gives you a much nicer syntax as a result. So I want to just talk about that quickly. You can kind of see, if you're learning iterators, where the iterators actually show through here. One last thing that I wanted to show off in terms of kind of features is one that we just recently added. I'm really excited about it. So let me go see if I can find my example. You can see I've got, this is from the New Zealand census data. I've got a 123 meg CSV file. And I'm going to load this thing. You can see I've pulled this up before. If I load this, right directory. I'm going to load this 123 meg CSV file, and it takes, a couple of seconds and can load it up. And then from here, the same kinds of things that you can do with different data sources, we can do here, but using data frames. And if you're not familiar with pandas or data frames, this idea that these columns of data can be stored in really efficient ways. So we can do operations on this really efficiently. So what I'm going to do is I'm going to make a variable. Let df equals this thing, and then I will do data frame group by, and the group that we're going to group by is years. So we're going to group all the years together and then work over each of the years. All right, so we'll let that load, and it'll do the little group by for us. And now we can start to process this. So if we wanted to say data frame aggregate and the max of each year, you see once it's loaded, I'm processing 5 million records in aggregate, like in a blink of an eye. So this is using some really powerful, really new technology called Apache Arrow and a crate called Polars. And I'm really excited to see this work become part of Nushell, become part of, right now, everything you have to say data frame and then something else. But we're looking at integrating this more into Nushell itself so that I can, if I'm just opening a CSV file and then I'm just doing where over different data sources, underneath, we're using the fastest, strongest architecture and engine to process that data for you. So it almost opens up doors that you're not used to having open in a shell anymore. It feels like we're stretching beyond a lot of what's common in a shell, and I'm really excited to explore that space. All right, let me quickly switch back to my original slides. And great. All right. Oh, wrong one. There we go. So that was kind of a demo, a little taste. Incidentally, I tried to open that same file in LibreOffice. It's like I gave up. It's too many rows. So I think it's really cool to have it in the system, to be able to have the flexibility to work with any size of data and to not have to worry about it. If you're curious about Nushell, so we've got the Nushell website, nushell.sh. You can, of course, go to the repo. We have a Discord. If you go to the repo, you'll see the Discord link in there as well. It's a pretty active Discord. If you have ideas or if you want to try it out and just share your experience, we'd love to hear about it. And Discord's a really great place to reach out and talk to us. Another one that I wanted to mention, Michael's actually in the Discord right now as Dashel. So Michael and the team at Couchbase are working on an extension to Nushell that takes Nushell and extends it with Couchbase functionality. He can kind of talk more about the experience there, but it's been really great working with them and seeing Nushell used from different points of view and from different areas to really help stretch it and grow it in a way that it kind of solves more solutions than the initial ones. So yeah, that's a lot of fun to see that take off. And yeah, any questions?